In the previous example, we looked at how you bring in a piece of 3D content into WATCHOUT and textured it in a simple and basic way. Now let's take a closer look at a slightly more elaborate example. Let's start by bringing in another set of content. I have here another 3D file. As in the previous example, this is a 3ds file. Which is a fairly standard sharing format that comes from 3D Studio Max, but that is read and written by most 3D applications. You can also use OBJ files, most Collada files, and a few other standard common 3D file formats. The only real requirement for using WATCHOUT is that the file must contain what's known as UV coordinates, which is what we are going to look at in a later video. But apart from that, you should be able to bring in most 3D files. Another thing to keep in mind is that the complexity of the 3D file must be reasonable to bring into a real-time rendering application like WATCHOUT. So if you have a very complicated 3D file, you may run into performance problems. But you'll notice that as long as it plays fine in WATCHOUT, you're good. I have two still images here, just like the earth texture that we used in the previous video, and I also have a video, and we're going to use all these three together with this 3D object here. So let's just bring in the whole folder into WATCHOUT. Now, as with any other content, WATCHOUT will analyze the content that you bring in, and that takes a little while. There's a dialog showing up here telling you that the media brought in is analyzed, and then it appears up here in the stage window. Okay, so let's start as we did the previous example by bringing in the 3D geometry, and it shows up right here. It just looks like a green square right now. So to actually see what this is, you may need to add some rotation to it so you can spin it around. And sometimes the objects come in the way you want them to. In other cases, they may come in backwards or upside down or whatever. And you can easily fix that in WATCHOUT by just applying a rotation along the appropriate axis. So let's zoom in on this a little bit here. I press Control key and I drag to zoom to this area. You can see that this is just our logo on a block-shaped object. You can see it has different colors as well, and we'll look at that shortly. Let's just look at another property before we do that. You can see that behind the 3D object here we have a single display. I'm dragging with Control-Alt here to scroll the stage window. You can see this rectangle here. That's a single display or a single projector. You can see this is slightly smaller than the display. The display in this case is 1280 pixels wide. So this is smaller. And what determines the size of the 3D object you bring in? If you look in the information column here, you can see that WATCHOUT has interpreted this as 1000 pixels wide, which kind of match because it's a little bit shorter than the 1280 of the display here. So when you bring something into WATCHOUT, WATCHOUT tries to scale it in an appropriate manner, and it does so by settings that are established inside the media element itself. So if you double click this to open it up, you can see that there is a setting here, scale to size. So you can either just set the maximum size you want of the object. So let's say you wanted this the same width as the display. You would type 1280 here, and it will scale the 3D object to be 1280 pixels wide. You can also scale by factor, and you can see it calculates the factor here. The scale factor in this case is 40. And this is based on the units that are found in the 3D file. Now, 3D files, many of the 3D file formats don't really have any relation to real-world units like meters or feet. They have their own units. So you always have to interpret that in some way when you bring in a piece of 3D geometry from like a 3ds or an OBJ file. And this is how you do that in WATCHOUT. And just to be consistent with other things that you specify in WATCHOUT, we do specify the size of the 3D object in pixels, which makes sense in WATCHOUT. And although you may not be used to it from other applications where you are working with other units than pixels for 3D content. But in WATCHOUT, we're dealing with pixels because most of the other things that we work with, still images, display resolutions, and so on, all are expressed in pixels. So that's how you set the size of the object. And I mentioned earlier that a requirement of a 3D file that you bring in is that it has UV coordinates, and those are two-dimensional coordinates that determine how images are applied to objects. And again, there is some discrepancy among 3D programs whether the U and V coordinates. U is essentially the X coordinate and V is the Y coordinate of the 2D image that you put onto this 3D geometry. And in some programs, the U coordinates goes in one way, and in others it goes the other way. So in some cases, when you bring in the image, you may see it's upside down or it's backwards, and that's why you have these flip textures horizontally along the U coordinate or vertically along the V coordinate. So sometimes you may need to check these when you bring in the texture if you can see, okay, that came in upside down. Okay, so let's go back here and see what we can do with this content. Let's zoom in a bit here again, Control drag to zoom in on this logo here. You can see that it looks pretty boring. It has these deliberately horrendous colors applied to it. So let's change that. I have a couple of images here. So I have this back color of this block here. So let's just take this, and as in previously with the globe, with the sphere, you have to select the Q first before you can apply a texture to it. So let's just take this and apply it to the block itself. And now you can see it has kind of a marble look to it. And of course you can spin this the other way around. If you add a rotation along the x-axis, that would allow you to see the top or the bottom of it. So in this way, we're looking at it maybe a little bit from above like that. You can position it by just dragging it like this. Okay, so we have a texture on the block itself, but you can see that this 3D object that I brought in, that has the background, and then it has the logo here. And if you spin it around, you can see on the back it's green. Okay, so this has actually 3 separately texturable areas, and we will come back to how you actually control that from the 3D file itself. That information is stored in the 3ds file that I brought into WATCHOUT. So that's not really anything you can control from within WATCHOUT. But once you see and can identify these areas, you can texture them. So I have another texture here that's designed to fit this logo here. And again, I can take this and just drag it, and I have to be a little careful with my aim here. I have to hit the logo. If I put it out here, you see it will go on the background here. That's not what I want to do. So let's put that one back, and then I take this one that's designed for the logo and I put it on. And you can see that the logo is now a little shiny. Let's see if I can move this up. Little shiny look to it, contrasting it to the background. Okay, and you can see that it does stick out a little bit from the front surface of this block here. Maybe it's easy to see if I spin it that way. Yeah, they can see them sticking out a little bit, and they also have some kind of a shiny surface applied to it that comes from this texture here. Okay, so we still have the back of the object. I'll zoom out a little bit here again so we better see what we're doing. So let's rotate it so we can identify the back. And let's do something different with the back. So on the back, I'm taking this video here. This is a video that has roughly the right aspect ratio for this area here. So I just take that video, and again I drop it onto the back of the block. So now I can make a little animation here. We start from out here, and we rotate it around to about here and maybe leave it there. Okay, so we go back to the beginning, we run this, and you have the video there playing on the back of the block. So that's how you apply different pieces of content to different parts of a 3D geometry that has been prepared with that in mind.